of sustainable development, green infrastructure, urban tree planting, and a very important topical area, stormwater management. Himself and his company he works for have many solutions that are very innovative, so I'm looking very forward to hearing several messages Jeremy has to talk about. He's an avid traveler, and it's my pleasure to actually welcome and learn from Jeremy this afternoon. So Jeremy.
Thank you. Thank you. Appreciate everybody's time and effort in the pursuit of sustainable trees. It's all right, I don't like standing at a podium. I walk around and look at people and talk a bit. But myself, as Richard mentioned, I travel the world. I meet fantastic people like yourselves and look at what their vision is in sustainable infrastructure. And it's very interesting in seeing the difference of what people are trying to create, whether it's arborists, foresters, landscape architects, engineers, all these different disciplines coming together to create a sustainable environment. And sustainable is probably an overused word. Probably all agree with that. Sustainable infrastructure, it's an overused word. And there's many reasons that it's probably overused. So we're going to go through a couple different points here. We're going to highlight some areas of designing trees into urban areas of landscape, and we're going to integrate some stormwater management opportunities as well into those different areas. I'll give you a bit of a history about our company. We were established back in the 1992 to provide research and to provide different solutions for landscape architects, foresters, and arborists around the world, and really to enable them to create sustainable cities through successful urban tree planting and sustainable stormwater management. So some different areas there. And there's some different types of applications that we can use not only here in Fort Worth, but different areas around the world. Now, sustainable infrastructure is a development that meets the needs of present society without compromising the ability of future generations to meet their own needs. That's the facts. How often do we look at sustainable infrastructure? We look at it as a vision of something we want to create, but when it's constructed, maybe 2, 3, 4, or 5 years down the road, it's no longer sustainable. We can change that, and we can change that one tree at a time. So the average lifespan of a tree in an urban environment is between about 3 to 8 years. Not very long. 50% of trees planted in urban environments don't reach their 10th birthday. We can change that. What's interesting is why we use the 10th birthday is because at the 10-year mark on average is where we start seeing the most benefits of urban trees, whether it's wind deflection, whether it's canopy collection of stormwater, whether it's noise abatement, all these different things actually start at about the 10-year mark and move onward. We know that tree root systems spread for anchorage of the tree. We're going to look a bit closer below the surface. We've got this slide here, which we can see of what we call a tree in a forest-like setting planted. You can see the extension of the root system there. You can see the buttress roots there close to the tree. About 80% of that root zone is the size of my thumb or smaller, what we'll call fibrous rooting. We know that healthy root systems make for healthy trees. But it's not only about the root systems that we're talking about here. We're talking about protecting trees above ground as well as below ground. So we kind of need the 3 Ps of tree planting. We need to plan, we need to provide, and we need to protect. And when we're planning, especially in open spaces, we want healthy trees in pavement areas, like we see right here. So we need above ground solutions, and we need below ground solutions. But we also need to understand what those solutions are and what the best systems or the best type of solutions work within these spaces. So if we're going to plan, are we going to plan for some retention of stormwater? Are we going to plan for some detention? Are we going to use it for filtration with stormwater management? What type of surface are we going to use? What species of trees are we going to use? What type of maintenance, as we just heard from Cecil, are we going to have on top of these different surfaces? And how many pedestrians are going to go over these spaces as well? We also need to make sure it's engineered. We need to plan for these spaces to make sure that the engineered areas meet the engineered loads of vehicle surfaces. And I speak to many arborists, many foresters around the world, and they tell me, we've got vehicles driving on top of our root systems, we've got roadways next to our tree planting areas, compacting the root spaces and killing the trees, effectively really reducing their lifespan. And it was interesting, I saw one of the slides here that Cecil had up, and it was the New York City's Plant a Million Trees program, which if we start thinking about that, think about that for a second. Planted 1 million trees, that's a lot of trees. How long will these trees last? Going by research and development around the world, over 500,000 of those trees won't reach their 10th birthday. That's not sustainable infrastructure, is it? So engineered systems are very critical. Having engineered systems and proven, tried, tested systems also makes for sustainable infrastructure and incorporating and designing trees into the urban environment. So when we look below ground, we need to understand what subsurface requirements are. And there's a lot of challenges we have. I was actually up in northern Canada just before I flew down here to Texas at an area where they had a lot of challenges, including below ground utilities and bedrock, similar to this picture what we see here. There's different ways of creating root zones to enhance root growth and benefit the growth of trees below ground. Sometimes it's in pedestrian areas, sometimes it's in roadways, sometimes you have the challenge, as this city has, actually of high bedrock, or sometimes you have utilities, or sometimes we can utilize the tree beside it, as we call linking tree pits and sharing those spaces like we see within this space. This is all part of planning for sustainable infrastructure and designing trees in the urban streetscapes. It starts in the area of the first plan, not during construction, to create this space. So we also need to provide. This is a picture of a project in Phoenix, Arizona, not far from here. And of course, in Phoenix, Arizona, they have monsoon season, and they got a lot of trees torn up. But it's not just about Phoenix, Arizona. We can go to the East Coast, there, New York City area, and look at Hurricane Sandy. Many, many trees uprooted. So anchoring the root system below ground is also part of providing for that space of root systems as well. With also planning and providing, we need to understand something like this. Now I know we're foresters here, we're arborists, maybe some landscape architects as well in the room, but how often do we dig a hole to plant a tree in the ground and we see something like this right here? Now it's actually an interesting visual because I had a call from the landscape architect that was designing this project at 4 o'clock in the afternoon, and she was extremely animated. And you can probably guess she wasn't animated in a good way because they told her to take these 5 trees and maybe place them elsewhere. And they were going to fill this with concrete and just cover it up. That was what they classified as sustainable infrastructure. There's actually 5 trees supposed to go in here. There's one right here, 2, 3, 4, and 5. Now this could be any city that we'd excavate a hole to plant a tree and see something below ground. So providing for the root system is extremely critical. Having the right system that fits in these spaces is also very critical. What's interesting about this is there's also 5 utilities competing against the tree. There's one right here, there's a second one here, a third one there. We can see that blue pipe, which is a 4th one, and where this gentleman's standing, there's a cast iron pipe going through right there. Do you think we're going to plant 5 trees in this space? Do you think we're going to get sustainable infrastructure? Do you think we're actually going to be able to design trees in the urban landscape with these kind of challenges below ground? This is where we start providing as part of the planning process. And this is what we're looking at here. It's not only about the trees, it's also working with the utility companies and with the different types of subsurface challenges we have in protecting them, whether it's a building foundation or a type of infrastructure. So what's happening here is you can see that these utilities have been protected by a barrier, what we call a rootstop barrier, to prevent root intrusion, increasing the lifespan of them. Utility companies start understanding that trees can actually be planted very close to the utilities and we protect them at the same time. This is where we start understanding designing trees in the urban landscape starts with protecting other areas at the same time, because that means we can actually plant trees closer to utilities and have increased volumes of soil as well. So when this is finished, we see something like what we see here. This is realization of 5 trees planted in urban infrastructure as a sustainable area. So now we need to protect these trees. Protecting trees actually starts above ground. Protecting the root zone is very important, but protecting trees starts above ground. This is actually a slide I took from downtown Toronto. What we're doing here is we're using it for some stormwater management applications. A bit hard to see, but there's actually a linear drain that goes along the curb there. And they're taking the stormwater from the surface and putting it below ground. Well, in Toronto, they use a lot of salt. Probably not a lot of salt used here in Fort Worth, but in Toronto, they use a lot of salt. In Montreal, they use a lot of salt. In different areas, you use a lot of salt or chemicals. So understanding and protecting those below ground spaces is very important. And also protecting the trunk of the tree and the root ball space is very critical. So when we look at this slide here, we look at a tree guard. And I know many cities don't like tree guards. I know many persons don't like tree guards because you can't lock your bike to the tree and damage the tree. But what we're doing here with a vertical tree guard is protecting the tree from something like what we see here. And this was actually very interesting. I was walking to a presentation early in the morning. Somebody had freshly locked their bicycle to this tree, as we can see here. We've got some immediate damage to the trunk of the tree. This is not repairable. This is permanent damage for the lifespan of this tree. When I came back an hour later from this presentation, this bicycle was lying on the ground, and its crank and lock had chewed itself down this tree, causing permanent damage from there downwards. The point of a vertical tree guard is actually to protect that space from animals, vandalism, bicycles, pedestrians, and vehicles. Now, there's a couple critical things I just want to note on vertical tree guards, and that is you don't want the tree guard to be too high that encroaches into the limb system and damages the limbs. Too often you walk down a streetscape and see the upper limbs hitting the tree guard. Not a good idea, causes weakness and decay. On top of that, you want the base and the top to be large enough to allow for root flare and the swaying of the tree, because that thickens the trunk of the tree and also promotes fibrous root growth. So a couple factors we need to understand when we're actually using tree guards. I've seen tree guards around the world that start at 8 inches in diameter with a 2-inch tree inside. That's not sustainable infrastructure. On top of that, when we look at the ground level, we look at something like a tree grate. And although the tree grates are decorative and allow for pedestrians to walk over top safely and have all those benefits, what they're actually preventing is what we see right here. So this is a picture I took in New York City. New York City calls this, I think, something about the 4x4 planting zone that they plant their trees in. And what we can see here is during a light rainfall, the soil volume, if we'll call it that, has less saturation point than the surrounding concrete. There's something wrong here. So when we plan and we provide, we want to protect these trees at the same time. We want to protect the fibrous rooting. We want to protect this open space, if it's uncompacted soil volume, to allow for pedestrians to walk over safely, but also allow for irrigation and aeration within that space. Allowing the fibrous roots to grow within the first 3 to 5 years from the space is extremely critical in increasing the longevity of the planting zone. And what's interesting in this is you can imagine New York City, they've got millions of pedestrians walking over top of this space, compacting that area. Now the number one damage to trees, tree fatality in our urban environments, of course, is these very feet we walk on. I was going down the Holland Tunnel. I don't know if anybody here has been to New York City, but it was very interesting. There's a sign there that said, "Stuck in traffic? Well, technically, you're part of the problem." And I kind of found that funny. I thought, trees dying? Well, technically, I could be part of the problem. So protecting the root ball zone is the point of a tree grate. And that allows for pedestrians to walk over freely. It prevents compaction. It prevents damage to the fibrous root volumes. It allows for irrigation and aeration within that same space. Aeration below ground is extremely critical in benefiting the growth of roots. And what's interesting, we've got a couple reports. I'll just note this. We've got a new one on our website that allows you to see root growth below ground next to an aeration pipe. And the difference is phenomenal. So this tree here is actually planted in the soil cell system, and this has a special grate system that allows for maximized pedestrian traffic in a constricted space. So this allows you to not only plan and provide, but protect the trees at the same time. Now, protecting the trees and protecting infrastructure all relate to the same thing. And this is actually a picture I took in Argentina. Walking down a fairly new streetscape you can see here, but we've got some root intrusion into this traffic zone there under those paving stones. Now, for less than $15, that could have actually been prevented with a simple, effective root management system along the back of the curb. So when we're planting trees, we want to look at how these trees grow. We want to understand the root zones, we want to understand the root penetration, and we want to protect the upper areas of infrastructure at the same time to protect what we see here. So this is all included in designing trees in the urban streetscapes. Now in saying that, we could say that yes, this might have cost $15 to prevent that damage, but how many dollars is it going to cost to fix that, and what are they going to do? Is going to damage the tree when they cut those root systems out. So we want to understand that as well as part of designing these trees in the urban streetscapes. So when we look below ground, I've got a couple different types of soil cell systems I'll show from around the world. Some of them are here today. We want to understand not only the soil cell system, but the volumes that it contains and how it functions within those spaces. And that's where we start with systems. Now here's an innovative soil cell system here that's in the UK. This one allows it to be a totally modular system. It's actually got the highest void content below ground, allows for large utilities to go through, it allows for vehicle traffic on top, and it allows for irrigation and aeration within that space. So here's one going in the ground. This is a very small system. Now, in saying that, we might not want to take that massive leap from going from maybe a 4x4 planting space to maybe 20 or 25 or 30 cubic yards. So this city, for instance, has taken small baby steps. They're going from about a 5x5 planting zone to a 10-foot by 8-foot planting zone to make those steps. Designing trees into urban streetscapes and sustainable infrastructure is like something like Rome wasn't built in a day. It takes a process to get through to where we want our targets to be. But that starts with the implementation of something like what we see right here. So sometimes we ask the question, what are different systems and how do they work and what are the results? So this actually is a trial project we worked with Bartlett Tree Lab on. It just shows different results in something like an uncompacted soil volume area compared to something like a sand-based structural soil and a gravel-based structural soil. So these are just some different applications and different ways of growing trees in our urban environments, all part of designing trees into these spaces. This just gives an understanding as a third-party test as some of the different results. So when we're looking forward, we might want to ask the question is, how long do we want these trees to live? Because by reducing these soil volumes, we can actually reduce the lifespan of the tree at the same time. So here's the growth rate. Let's just do a soil cell comparison versus structural soil comparison in 1-year growth rates. This is once again a third-party test, 2 Chinese elms as a test plot. And what we say here is it's not the size of the planting area that counts, it's what's inside the planting area that counts. So we've got 2 spaces, identical in size, identical species of trees, identical planting and maintenance on the same day, but completely different results. Now sadly this tree has died since this picture, but you can see it's not performing very well in that space. So when we look below ground, we don't want to know just how big the space is, we want to understand what's inside that space that actually benefits the growth of trees. And this is where we start understanding different types of root pattern as well. So if we look at a comparison, soil grows trees, we know that. In saying that, I've been around the world, I've been to Australia, I've been to Europe, I've been to England, I've been to Argentina, Canada, the US. I've never actually seen a stone that grows a tree, not yet. I don't know if anybody is here, I'd be interested to speak to them if they have. But what we see here is the factors are, in this picture, we see about 20% soil volume compared to this system, which is showing about 95% soil volume. So when we look at a constricted streetscape, we could actually reduce this to about 1/5 or 1/4 of the size and have the exact same amount of soil volume that's uncompacted for immediate root growth within these spaces. Understanding what's below ground is critical to gaining what's above ground. And designing those starts with these type of systems. Having a full system benefits the growth of trees indefinitely to the different areas of our areas of urban streetscapes as well. Now when we look below ground, we also want to look at some applications and projects because pervious concrete is becoming popular and taking stormwater from different areas and putting it below ground is also popular. And integrating this into tree planting systems is an exciting space. And not only do we do that here in America, but we do this at a global level. And understanding these applications will help us as we move forward in the industry and benefiting these spaces. So we're just going to take a look at this slide here at Toronto. Toronto's got a very high standard for tree planting. Now, I'm not sure how many people understand the metric system. No harm if they don't. But the City of Toronto's target soil volume for one single tree by itself is approximately 30 cubic meters of available soil volume. So uncompacted soil volume. When we link the trees together or share the spaces, what we're doing here at Toronto Union Station, they look at about 20 cubic meters of soil volume. So we typically use a number of about 80% shared space. So if we have two trees, for instance, that have 10 cubic yards each, if they're linked together, we have approximately 16 cubic yards of available soil volume. Now this does change slightly in the industry, but that's a typical factor that's used. So when we look below ground here, below Toronto Union Station, there's a whole subway terminal. So the challenges of maintaining and gaining these soil volumes was intense. But because it started in the design stage, these trees, not only when they were planted, but further on, have been extremely healthy. We're also going to look further down into the Chicago Navy Pier. Chicago Navy Pier was an exciting space to design. I worked with a client in this area. It was a slab-on-slab design. So there's a lower slab, and then there's some soil volume requirements, and then there's the upper slab as we see here. Just to give you an understanding, these trees in this picture are similar to the size when they were planted. The root balls are about 8 feet in diameter, so very, very large trees. Maybe too big in some sense. But what we can see here, these trees are actually thriving. So in benefiting that and understanding the design starts below ground and moves upward. We also have some applications where we have pervious concrete surfaces or pervious paving stones. And that's what's showing here in this Main Street Markham project. Sometimes we don't have soil volume requirements that we can gain within the pedestrian area. And that's the challenge we see here on this project. Within this area below ground here, we actually have a lot of utilities. So what they've chosen to do is actually link the tree pits across the street. So they have a whole soil cell system below ground here, sharing soil below the street. So we can actually look at these systems and say, well, gee, we can't gain the soil volume in the pedestrian area, but maybe we can use the street or some of the drive-by areas in the parking zones. We can actually share spaces like we never could before. And you can see these trees are starting to thrive after about a year's growth rate. Here's a project in Virginia where we wanted to protect a sound barrier wall. Once again, it's an open planting space, but we wanted to support the roadway and protect the wall system. So again, providing for these spaces counts not only in design, but also in construction. And this gives an idea of the installation of how these systems go in the ground. So whether it's on structure or whether it's an urban streetscape, designing at the beginning is very critical. This project here is actually on a building structure above ground, up on the roof. Now, I do know some arborists and some foresters that don't like trees on roofs for multiple reasons, but if we design the system correctly and provide the soil volumes, we're actually going to get enough anchorage of the root system in this space that we're going to be able to hold that tree in the ground and prevent it from coming off the top of a building. There's actually been a couple areas I've been where I've seen trees on the top of buildings that are starting to come off. Allowing for proper soil volume, allowing for the proper design below ground will provide for a root anchorage to support these trees. So when we look at pervious surfaces, this is also another space. We can start looking at the soil volumes below ground to retain water. Now, this is already happening around the world, and there are some factors that we're working with places like Baltimore, Washington, Philadelphia, Toronto, Kitchener, that we're taking stormwater and retaining it on site. And everyone has different calculations, but we could utilize this whole space below ground to hold stormwater for tree planting, whether it's empty and we retain it and allow it to disperse into the planting zone, or whether it's full of soil and we allow it to be held within that same space. So soil typically holds about 20 to 25% retention of moisture by mass. So for instance, if we had 10 cubic yards of soil here, we could effectively hold 2 to 2.5 cubic yards of stormwater within that space for root take-up. in any condition, we want to make sure these systems are designed correctly. Oversaturation of a tree pit is not an exciting event for the tree. A lot of trees don't grow well in bathtub situations, do they? There are a couple that do. And saying that, designing these trees and these systems is very important. And we could, for instance, in Texas or Florida, where I was last week, take stormwater from the top surface, whether it's through the catch basin into this and disperse it, or we take it from pervious pavers, or a linear drain on the back of the curb, or from a building structure and put it within this space. There's many different ways of designing trees with stormwater management within these spaces. As I say to everyone, this is the way the world's going. Let's pursue it. Think of the stormwater retention we can do here in Fort Worth, or your own community. Instead of it going down into the treatment plant, or if it's a combined sewer, we can reduce this at the site. Some of the engineers, I won't ask if there's any engineers in the room. I work with a lot of engineers around the world, but some of the engineers are actually starting to look at trees as benefits, as part of their BMPs, about part of their best management practices. Because they're looking at saying, you know, this tree supports this much soil, which supports this much stormwater management retention on site. So we can actually infiltrate these systems. Now, we've been doing this for years and years. This is not something that's new. This has been tried, tested, and proven, and it does work. We've got reports showing the removal of solids, the total suspended solids. The designing of these systems is very critical, but the functionality is amazing. Yes, it works. You can have trees that will take 10, 15, 50 gallons even of stormwater up per day in root take-up. So if we're stormwater harvesting in the tree planting zones, as I said, it's extremely site-specific. I've been to many projects where they have not designed it correctly, so we work with our clients very closely in that, for instance, because in any condition where you're bringing stormwater into the planting zone, you always want to make sure there's a drainage layer to allow for the oversaturation point to come off and run off. We call this the Arbor flow system at our facility, but here's a project in Toronto where they're actually taking stormwater, running it off or sheeting it off into this linear drain, and then this is in turn going back into the planting zone and used for supporting the healthy growth of these trees. Now, some of these systems, the linear drain systems, you can actually shut down during the winter months. So if they have a high salt content in the area that they're putting down, like in Quebec City or in Ottawa or Montreal or Toronto, they actually shut this system down during the winter months. Or if it's a place like Texas or somewhere in the southern climates, this can be open all the time and allow for that water to recirculate and be used within this space. Now that's what we call the root rain linear drain. That's just a picture of it there to give you an understanding of what that looks like and how it functions. This again is a project in Toronto, but what we can see here is this whole linear drain system is taking the stormwater from this planting, this hardscape space, and putting it into this planting area. And there's another one on the back of the curb, which is this inset shown here, and that's taking that and putting it down into the tree planting zones. Irrigation and aeration below ground is very, very critical to the growth, the factors of root growth, and allowing this to actually fundamentally function within the space also will allow for maximized root growth. So it could be from a simple catch basin system like this, or it could be from a bioswale through a linear catchment area like what we see here. There's so many ways to design these different systems, but as I said, this is the way the world's going. Let's pursue it. Let's work with it. Let's make it happen. Let's design trees in the urban landscapes. Let's use some stormwater applications to bring these different areas together and also allow for that stormwater to retain on site. This is actually an exciting product called the Curb Flow, which is from the UK. It's actually, I think, from where the last speaker, Cecil, was from. It was designed. This can be opened and closed during different events to allow for different amounts of stormwater to be controlled into something like a tree planting zone or a bioswale area.
Is that manual?
This is a manual system, yes. Yeah, so that's actually the key that goes in the top, just like that. So designing trees in the urban planting urban areas and controlling stormwater through design is very critical. This is actually a project in Thunder Bay, Ontario, up in Canada there, where they wanted to use their parking areas for retention of stormwater at the same time as planting trees. So what we can see here is actually a raised planting area that's going to have hardscape on top. You can see some utilities and light posts in that space. These two areas here are where the trees are going, and this actual area underneath here is going to retain stormwater. So they're bringing stormwater from the surface, from the parking lot surface, retaining it in these two areas on each side, and then there's a raised curb which allows this to leach in to that planting zone and saturate within that space. So you can design pretty much anything, anywhere, if you have the right system and solution. So with that, as I mentioned, we call this the Arbor flow system. The Arbor flow system is a specifically designed system for taking stormwater and putting it into the root ball space. This system here is a 2-stage filtration system. There's also some that are a 3-stage filtration system. What we're doing here is trying to remove the total suspended solids. We're trying to purify some of that water, and we're trying to use that for stormwater take-up with the root systems. I've actually got an animation here, which I hope will work. I'll see if this does work. That gives you an understanding of how this actually works below ground. So as you can see here, we've got a rainfall event. This is taking about 10 parking spaces in the lanes going through to them to one tree. That's the first stage filter there, which is removing the large sediment, large debris. From there it goes to a second stage filter that removes some of the silt, contaminants, and salt before it goes into a third stage filter, which is up in here. That's actually a bioswale, and that takes out the hydrocarbons and the rest of the salt before it infiltrates into the root rain system that penetrates down to the second layer, starts saturating the soil, and if there is excess, in turn, it goes out the base and doesn't collect in that space. This is the world-leading technology in stormwater management with tree planting. This has already been implemented around the world. It's actually been utilized in just outside of New York City as well. This is how we can start utilizing stormwater management with tree planting effectively through design.
What is the backfill in the cells
The backfill in the cells?
that holds the stormwater?
The soil specification, I'll speak as that momentarily, is uncompacted soil, typically a good sandy loam. There are different soil specifications dependent on what you're using it for and even the tree species and the areas that you're within. In this condition here, we want a fairly free draining soil with maybe a slightly higher nutrient content. The company I'm with, we actually have multiple soil specs, but a lot of the different cities and the arborists and the foresters and landscape architects have their own soil specifications as well. So you can choose any type of soil to go in it, or you can use one of the soil specifications that we actually have as well. It is completely uncompacted. It is not compacted at all. So allowing you to design and work within these constraints helps us understand the benefits of these spaces. This is actually a project that was funded on a funded urban revitalization project in Australia. And they've taken the center median, and it's a bit hard to see, there's actually a street on the other side, and they filled this whole area with the soil cell system below and allowed for maximized infiltration through a 3-stage filtration system. So you've got the one stage here as a rain garden, second one here as a bioswale before it actually hits the tree planting zone as a 3rd stage filter. We can design anything. We can make it function, and we can realize that we're going to get the benefits of healthy trees in our urban environment. Now this is very interesting. I was at a project here where we removed the trees after 10 years of planting to plant new trees. So I just want to speak as to this for a second. We look at this tree here. It died long before its 10th birthday. But what we can see here is after 10 years of being in the ground, the shape of the root ball is almost identical to the day it was planted. How many people have seen a picture like this before? Yeah. Is this sustainable infrastructure? No. So what they did here, and this was a test plot, they put in 7 new trees with lots of soil below ground. And here's a photo right here. So you've got new planting area, you've got new concrete, 7 new trees lined up here with lots of soil volume and a soil cell system below ground right here. It's not just about soil. I want to reemphasize that. It's not just about soil. It's allowing the soil to breathe. It's allowing the soil to get nutrients. It's allowing the roots to be managed into those spaces. So 7 new trees, lots of soil volume, and I took a picture a year and a half later, and this is what I saw. This is not sustainable infrastructure either. So in understanding that, right when we take a hard surface like concrete and put it over top of soil, we create a containerized tree pit. Now, soil is a living item. It's got millions of microbiological processes happening all the time. It requires air to breathe, just like you and me. And some people that don't understand that, what I'll ask them to do is go outside and take a little scoop of soil out of a garden, put it in a plastic bag, and leave it on their desk for an hour. And what happens? The outside gets wet. Soil needs to breathe, just like you and me. Right when we cover this with concrete, that soil becomes stagnant. You get a lot of organic gases build up. Organic gases cause root dieback. We need this to breathe. Having an irrigation aeration loop through this is critical to balancing the growth of the roots within that space. On top of that, if we don't manage the roots down into the planting areas, where do roots want to grow typically? In the highest profile of soil volume that they can. So instead of going down into this soil volume here, you can see these tree grates have all lifted. These roots actually started growing up because there's nothing managing them down. Managing root systems is just as critical as putting soil volume next to them. Roots just don't know, oh, there's a whole bunch of soil volume there, unless we start managing them to it. On top of that, where's the worst place to plant a tree? Other than on an airstrip or in the center of a road?
Under a power line.
Under a power line, that's another good one. Right next to the roadway like we see here. But in some conditions, this is the only place we can plant them. So if we're planting them there, especially like this photo, like what we see here where there's a lot of snow, we want to protect the root ball zone from being damaged from something like high concentration of salt. So in this condition, we would recommend a horizontal barrier just over halfway around the tree. So when this area here has a massive pile of snow, of course that snow has to melt someday. Where's that water going to go that's full of salt? Right into the root zone. This will allow it to run off behind the curb. Sustainable infrastructure starts in design with the proper systems to meet your vision in creating and designing trees and the urban streetscapes. And saying that, we also want to implement some stormwater opportunities. That's very important to start in design too, because there's so many factors that are involved, including amount of rainfall, amount of surface that's being taken up and put into those root zones, amount of soil volumes, and of course, budgets. And saying that, here's a project which is phase 4. It's just outside Detroit. These have been in the ground for about 5 years. On the first phase, this is the third phase, and you can see the trees are very healthy. You might have different types of systems right across the street from each other, like we have here. Now it's a bit hard to see, but there's a smaller tree planted right here. It's in a completely different system than this tree planted in that tree pit fence. So this allows you to balance out soil volumes and different systems to meet the requirements that you have. Now ourselves being the pioneers of soil cells in an exciting space, I thought you guys would be interested to see the first tree ever planted in soil cells. Very few people have actually seen this picture. It's not a large tree. It's multi-stem English oak. This picture was taken last year. It's probably about 5 cubic yards of soil for this tree, so not a huge amount of soil. We can see there's a laneway on one side, a roadway on the other, parking on each side of this tree, yet since 1992, this tree has not only grown, but flourished. I'm going to tell you something interesting because this is something that we're really excited about for our company here because we're hoping to do something similar. This picture was actually taken in the UK. They're the pioneer of soil cells. And what the UK has actually just introduced just about a month ago, and this is unheard of globally, and I'm sure you as foresters and arborists are going to be excited about this, is they have just introduced a program where they guarantee the life of the tree to 15 years and onwards, not just growing, but flourishing. Since 1992, they have millions of soil cells below ground and the different systems that you can check us out at our booth down there with some of the systems to understand how they work, but they've never had one callback or failure that they know of. We're here to design trees in the urban streetscape. and I thank you very much. Thank you.
Thank you, Jeremy.
Thank you.
It's always neat to see innovative new approaches. The one thing I learned that was pretty neat today was shutting off a system for de-icing salt, which is pretty interesting. Never heard that before, so thank you, Jeremy.
You're welcome.
See you.